is audible.
Yes, perfect.
Awesome. So we would like to thank everyone for dedicating time and joining in to this rather unique session on Introduction to AI, Deep Learning, and Artificial Neural Network for Oil and Gas Industry. This session is a part of two-day session that is going to conclude tomorrow. In these two sessions, you're expected to be introduced to AI and different AI technologies and basically what AI can do for you in oil and gas industry. The information that is going to be presented in these two parts of sessions, it's not general knowledge. It's knowledge that's derived from experience and basically training lots of people on this as well. And yeah, trying to implement the newest technology in oil and gas industry. So AI is a very, very broad topic. So what we are going to dedicate our time to is how to predict problems, how to predict what's going to happen, and how to try to solve some of these things and basically get some insights from our data. So that's really, really the core part of what an oil and gas people usually do. By the way, guys, AI, it's not always about ChatGPT. ChatGPT is just a really tiny part of AI. There are lots and lots of more capable models than AI that basically can really, really target and solve your data. So before we start, my name is Nashat Omar. I have been working in the oil and gas industry for more than 12 years. I specialize in production and flow assurance engineering. And of course, I do data science in my domain as well. And machine learning and AI is a part of my day-to-day job. So before we start anything serious, let's understand what an AI is and why AI suddenly became so important in oil and gas industry. Okay, so it goes like this. Whenever you're trying to work with a situation or whenever you're trying to work with a problem, achieving the solution to the problem, it's not always straightforward. Okay, so that's why AI is being used. Now that's the bottom line. But what AI actually is? AI is actually a simulation of human brain. So basically, we want to simulate how human brain works and how human brain understands pattern. And at the end, we want to predict something or we want to understand what's going to happen in the future. Okay. So this is basically what an AI is. It's something like a simulation that you do that's going to be intelligent and of course aware of the data. So in order to achieve this, or in order to understand what's not going to happen, or in order to learn things from data, we have few approaches that we can do similar things. We have the AI, which is actually there is the big umbrella and is the dream that human being has been perceiving for the past 70 years. So still today, we have not achieved the true AI yet, but we have achieved close enough. So for us to create solutions that are basically data driven and we basically drive insights, not from regular industry equations, but rather from data. So usually AI in oil and gas industry is divided into two parts. And of course, we have newer parts are coming to the industry as we speak. And we are also going to see some of these in tomorrow's session. But the main two parts of AI in the industry is machine learning and deep learning. So what is the difference between these two? Machine learning is your classical models. Basically, these models, some of these were invented in the 50s. And yeah, they are still being used today. They are extremely powerful and effective, and they are extremely fast. To this date, we have created more than 6 or 7 trainings on this, and lots of people have participated in these types of machine learning trainings we created. And the newer tools that was introduced back in 2019, and basically it became mainstream, not in oil and gas industry. Later, it became mainstream in oil and gas industry, but still people still are picking up on this, which is deep learning and artificial neural network. So deep learning and artificial neural network, it's not a model, rather than an architecture of solving something that's really basically simulating humans' brain. Okay, so the deep learning is actually the newer era of AI, and basically you will do your predictions with this. And basically, it requires lots and lots of data, and that's why it's perfect for us nowadays. So the global oil and gas market, it's projected to grow a lot in the upcoming something close to upcoming 7 years. So it's really going to grow 14%, the rate of digitization and implementation of AI. If you did not know that already, in the industry is always pushing towards the AI. And of course, as we said, AI is not just ChatGPT. There are lots and lots more in AI that are more effective than ChatGPT. And you will see some of these examples firsthand in these sessions. And so why AI and why now? So back in the 80s, in the 70s, the idea for AI was already there. Some of the models were already there, but why could not we implement these back in days? So the biggest hurdle back in like 50 years ago, it's actually we did not have enough computer powers to do this. Plus, if you do this, well, who's going to use it? Well, day-to-day users or engineers, they don't have computers on their own desk. That was the problem. But once computers started to evolve, now suddenly this hurdle, it's not an issue anymore. Now each household, each person on the work, they have not sometimes not just one laptop, one PC. Sometimes one person has like access to multiple PCs at the same time. So that's not a problem anymore. So why we're using AI nowadays? Number one, the problems that we have in the industry, it's becoming harder to solve. That's for due to various of reasons, because we're using lots of new technologies that did not exist yet. So some of these things are not very straightforward. So that's why some of the problems are really hard to solve nowadays. Plus, we have vast data volumes, and this we cannot emphasize uh, on this problem. So nowadays we are getting lots and lots of data. So we get daily data. We have monthly commercial data. We have even sometimes we have minutely data that's coming from the field. That can be every 5 minutes or every 30 minutes or sometimes every 30 seconds. In drilling, well, this is going to be on second basis. So yeah, you can see like we have really, really large of volumes of data. And most of the time, we don't know what to do with these data. Of course, AI is an outlet for this. Plus, we have increased number of assets. So the number of wells, the number of equipments, the number of fields, the number of, let's say, facilities are, of course, they are growing every year. And once you get things growing every year, well, you need more engineers for this. You need a way to control of these. And of course, the rate of employment, it's not as fast as the growth of these assets. So that's why we have lots of tasks to cover, lots of things to do, but little resources of human beings. Plus, the experience in the oil and gas industry, it's diminishing year by year because we don't have lots of workforces coming into the industry, and the senior people are getting retired. So AI can be a part of the solution for this the big problem we have. Plus, we are having lots of unconventional resources that don't follow a certain production pattern. They don't follow a certain let's say management pattern. So that's why it's really essential to set rules on working with these, on to model these using a data-driven approach. That's something that you're going to see. Now, before we dive any deeper into AI, let me show you what oil and gas industry is about. Oil and gas industry, it's basically dominated by three main equations. And I am just simplifying this, by the way. So the oil and gas industry is dominated by conservation of mass, conservation of momentum, and conservation of energy. And these three equations, of course, derivatives of these equations and different forms of these equations dominate the flow and dominate the reserves and basically hydrocarbon volumes we have in different parts of our industry. For example, same equations applies in the wells, flow lines. Well, not the equations, but the phenomena apply in the wells, in the flow lines, in the reservoir, in the processing facilities, in tanks, in custody transfer. Like any combination of these usually apply everywhere in the oil and gas industry. Okay, so where do we operate in the oil and gas industry? Well, we operate in this triangle that intersects between all of these things. Well, you might say that that's a good thing. We already know these equations. We can solve some of these problems, if not most. But yeah, it's not that easy. Let me show you why. So if we want to describe the problem in oil and gas industry fairly accurately, we have to basically tell the computer to solve for really, really large sets of data, for really large sets of variables. And then we need to find the relationship between these variables. And then basically we will plug in those values. And hopefully we will get a generalized formulation of the laws that you saw. But we are really, really far from achieving this. Here's why. In oil and gas industry, you have different conditions. And different conditions poses different sets of constraints. So that's number one. Number two, in oil and gas industry, sometimes we work with three-dimensional spaces, including time that's going to be four-dimensional spaces. Sometimes we work with single-phase problem. Sometimes we work with three-phase problem. Sometimes we work with three-phase and then two solids phases. So that sums up to 5. It's really hard to model these things at the same time. So that's why we have generalized formulation of conservation of laws. For example, the formulation that you see below, it's for tubulars, and the formulation that you see below is for porous media. But both of these, they have the same structure, and basically they have the same root. The problem is these equations cannot be solved directly. The problem is you have lots of uncertainties in these equations. You have lots of parameters that you don't know about. You have lots of parameters that you know about, but you don't know their actual values. Okay, so for example, if we consider an oil and gas field like this, and we know that each well we drill, there is a certain permeability that associated with that well. Yeah, but the permeability between these wells, we don't know. The porosity between those wells, we don't know. The unique geological features between these wells and between all the assets we have, we don't know. So that's why lots of uncertainties in these parameters. That's why engineers in oil and gas industry, they usually simplify these problems. They start to assume different things. And once you start to assume things, the equations are going to be easier to solve, but the answers to your problem is going to be approximate. Okay. And the same thing goes for the porous media. Now, why AI can solve this problem? AI can solve this problem because AI can learn from the data. AI can devise these rules or understand these rules implicitly from your data. And this is called pattern detection. So let's see what are the types of problems that can be solved with AI in the oil and gas industry. And of course, this is not just not a comprehensive list of the things that you can do. This is just a really brief list that I compiled. There are hundreds upon hundreds of use cases for AI in the oil and gas industry, and these are just some of the important ones. And of course, you can take any of these problems and then decompose them into like really smaller problems. So you can use AI to predict the operational parameters or operational parameters like flow rate, like pressure, temperature, and changes in phase properties. All of these things that usually change with time and operational parameters. So yeah, this is one of the things that we can predict. We can drill ahead. So drilling ahead is actually a technology that's built on AI. It means that you know what you're going to see in the upcoming footage while you're drilling. Okay, so this is called drilling ahead. And this relies on AI to determine what's the lithology that's going to come up and what is the optimum parameters that you should set your drill bit to for these, let's say, for these upcoming footage. We can also do event detection. So event detection is basically whenever you're trying to know what's the current status of a certain equipment. Is it failing? Is it working properly? And yeah, so all these sort of things. This is called event detection. So there is another way of doing it, the event detection, but that's going to be for the future, which is called early event detection. For example, let's say you have hundreds of wells, and all of these wells, they have, for example, different artificial lift types. For example, you have ESP, you have second rod pumps, you have some PCPs, and all of these things need monitoring. Okay, so you need to know when your ESP is going to fail. So in order to mobilize the crew and then basically schedule some workover schedule and maybe order some let's say, some job on a certain well. So all of these things and planning for these things usually starts from early event detection. Early event detection is basically can be done in multiple ways, but the most accurate way by far is using AI. And of course, this is very subjective because it requires lots of human intervention, at least as we are speaking. Plus, we can identify lithology. We can know what the formations are going to be based on our well logs. And yeah, based on, we can also automate well log interpretation. And yeah, but we need lots of data. And this is the core idea of AI. We need lots of data in order to discover patterns. So the first two parameters or the first two problems, these are known as regression problems. And you should, I think you've already heard of this in many places. So whenever your inputs are number and the outputs are also number, this is called regression. And whenever your inputs is numbers and the outputs are events, or the output is going to be text like shut-in, like tripping, like uh, levels and things like that. This is called classification, or even lithology. These are called classifications. These are really two common problems that we solve with AI. It does not matter the type of the AI you use. It does not matter the type of the model you use. So all of these things are basically baked into AI. Plus, we have pattern discovery, which is basically you start with a known data set, and then you will try to figure out what is the patterns behind these data and how this data can interact together, and which data looks alike and which equipments they really different from each other, which things can be grouped together, which things are really far apart from each other. So all of these things can be done with AI, of course. And we can all, by the way, now we have a newer contender in the AI industry, which is called the generative AI. In the generative AI and in an older type of AI, which is called an NLP. NLP is basically natural language processing. Based on these packages and based on these technologies, you can extract information from PDFs. For example, let's say your corporate has thousands upon thousands of daily reports, and basically you don't want to go through all of these reports. So what you will do, you will push those into AI, and then AI will learn the patterns, and basically you will start asking it questions, and it will basically pull some of the answers from some of these PDFs alongside with the resources and the references as well. So all of these things are done using deep learning. These are just really brief list of what you can do with the AI. And of course, the comprehensive list can go on and on and on. Now, nowadays, what are the technologies are being used? Of course, the technology for AI, it's very different back in the like 20 years ago. Okay, so 20 years prior, people used to use MATLAB for AI. People used to use C++ for AI. And to be honest, that was only in laboratories and only in the academia setup. That did not cross to the industries. But nowadays, in oil and gas industry, we have a certain set of technology setup that we usually use for these types of problems. And in the oil and gas industry, the most common language, up to like 95% that's being used in the industry, is Python. So most companies, if not lots of 99% of the companies are using Python. And Python is free, it's open source. That's why companies allow Python to be installed on their PCs, of course, with some permissions from the IT. So what you see on the right-hand side is all the technology stack that goes into building AI technology. And of course, you will learn these step by step. It's not going to be like learning everything at the same time. No, you'll learn a little bits of some things. For example, you will learn how to plot first, and then you will learn how to manipulate your data, and then you will learn how to prepare your data for AI. And suddenly now you're in the realm of starting to basically applying AI and training your model. And yeah, so basically things are learned in a stepwise. It's not going to be having everything at the same time. But yeah, the journey of learning AI, number one, it's very fruitful because this is the trend for the industry. And by the way, if you think that AI is a hype, no, actually we are way beyond that. AI was hype in 2015. We are not in 2015 anymore. We are 10 years behind. So yeah, It's projected that the industry will pick up AI fully, like basically in 2030 or some in 2020 in 2029. So we have like 4 or 5 years left in order to recap with all of these tools and all of these technologies, and basically we start to embrace them. Uh, let's take a look at, before we start coding, let me show you some of the classical machine learning models. And these are the classical AI models. By the way, these are still used. I am not saying that these are not used. No, actually, they are still used. They are very, very effective. Okay. So basically, you can think of, we have different tools for different problems. Well, same problems with different data sets. So the classical machine learning model are basically a branch of AI that basically uses simplified machine learning models in order to understand, or basically in order to mimic human brain capabilities. Okay, so some of these models are clustering algorithms, instant models, linear regression models or multilinear regression models, tree-based modeling, bagging modeling, which is also based on trees. So yeah, these are all of the things that basically people usually do, which is called classical AI. So the good thing is, if you want to apply AI in the oil and gas industry, so you need to keep in mind these things. Okay. So first of all, you need to have a good understanding of the oil and gas industry itself. So that's why these trainings are not designed for people who are actually students. These trainings usually designed for people who are already professionals in the oil and gas industry. Otherwise, people who are students, or they don't have their degree yet, and then they then don't have exposure to the industry, like proper exposure to the industry from 3 to 5 years, well, they are not going to benefit from this training because they don't understand what they're looking at. But people who are professional in the oil and gas industry, those are the candidates for these types of trainings. Those people are basically the right fit to learn these types of stuff. Okay. By the way, if you think that it's not your job to learn AI, and you think that it's someone who with a computer science degree is job to learn AI and then apply it for you, actually you will be wrong. Do you know why? Because oil and gas industry has lots of empirical assumptions, and it will take a really really long time for people from computer science background to learn these things, if they even learn it properly. That's why we spend upon tens of years in the oil and gas industry. Still, we don't know everything. So that's why people with proper knowledge in the oil and gas industry are the right candidates to start diving into AI, not people with a computer science degree. You will start to reveal insights from the data. You will create predictive models. You will understand what's going to happen in the future or what happened earlier in the time. Uh, Plus, you will start to become a leader of the neural evolution. You will start to combine the domain knowledge alongside with the machine learning and AI knowledge and drive some cutting edge technology. You will identify well and reservoir problems earlier, and basically you will start to understand how basically things will start to behave. This is all based on the data and what the AI is going to generate for you. And of course, you have to have enough knowledge of what you're looking at in order to understand what the prediction that you're getting. Now let's move on to the topic of the day, which is neural networks. Neural networks, it's not a new invention. Neural networks been actually, the first neuron or the first model was invented in 1943. But yeah, we said that computers were not strong. People did not embrace it very well because there are no outlets for it. How you can apply something that's only a theory? But in the 70s, certain things were started to work because we had some computers, and afterwards in the 80s we had like some technologies invented in order how to properly calculate these things. Okay, afterwards in 2012 some more architectures came around, and basically in 2019 and 2020 things became very mature in Python. People started to embrace AI and started to embrace deep learning. So yeah, that's a really brief recap of the timeline of neural networks. So in neural networks, this is what the network looks like. Networks is basically sets of nodes that are connected together, and basically each node it's connected to all the other nodes. So they are really really interconnected, and they basically exchange data between them. So once they exchange data, hopefully this data exchange, it basically it will modify and basically it will improve your predictions. These data exchanges between these nodes basically looks like data exchange in the human brain cells, and this is basically what these perceptrons are mimicking. Once you exchange data, and once the data gets filtered, and once the data gets improved over time with training, hopefully you will start to detect patterns. So this is what a neural network is all about. Of course, we have different structures of neural networks. We have things called MLP, or multi-layer perceptrons. We have something called single layer perceptron. We have something called RNNs, or recurrent neural networks. These are basically designed for production problems. Okay, so you can target production problems with these. There are sets of other more advanced networks which are called convolutional networks. These are usually used for mapping purposes, contour mapping, basically well spatial problems. So all of these things can be solved with convolutional neural networks. Okay, so this is what a workflow usually looks like. Basically, you will start to identify a problem, number one. So you'll identify a problem, and then you'll start to collect data, and then you need to decide what's the type of data you have, and then based on the type of the data, you will understand the type of the problem you want to solve. And once you understand the problem you want to solve, you'll start building the model and training the model, and then you will evaluate it, and you will decide if you want to see the results or not, or you want to publish the results or not. So this is a really simple recap of the things that you can do with AI. Now, let's stop, or let's enough on the theory. Let me show you some actual code. Okay, so a disclaimer. Before we start showing you the coding part, it's extremely important to understand you're not going to understand all the codes that you're seeing because you're not properly trained on Python. But if you join the full training, everything starts from zero. So you don't have to worry about that. We're going to take from you, we'll take your hand, and then basically show you like all the elementary steps that you need to go through in order to achieve a proper AI modeling. Okay. So the first thing that we're going to do, or the first example that we will do today, it's going to be this. I have a data, or I have certain training data. So we have lots of well logs. So we have well logs from 6 different wells, and these are all different files. Okay, and you can explore them. Okay, so now what do we need to know, or what we need to solve? We need to understand if there are patterns in these wells, or if there are some patterns in these tracks of well logs, and that's exactly what we're doing. Okay, so the first thing that we're going to do is we're going to read all of these well logs, and we will start to basically compile them into a single database. Okay, so let me show you how we can do this. Okay, so the first thing that we will do is basically there are some things that you will import. Okay, so we don't care about these. As we go through them, I will show you one by one what these usually do. Okay, so the first thing that I'm going to do is I'm going to read the well log files. So I already have some class that basically helps me to read these files. So these are what the files look like. Okay, so we have 10,000 rows of data, or 10,000 rows worth of data, and of course this is just from 6 wells. If you have like more wells, well, you are going to get sometimes you will be very close to 1 million rows. So the more data you have, it's the better for the machine learning. Also, but it's better going to be for the deep learning. Okay, because it's going to learn lots of things. Okay, so this is what the data looks like. The first thing that I am going to do is I'm going to explore the data. I'm going to show you what actually the data looks like. Okay, so let me show you something. So let's save all the data we have from the well log, and then let's start to visualize them. Okay, so for visualization, usually we have things as a layer in Python. Different things basically comes into layers. So each time you want to do something, you will add some certain layer on top of this. Okay, so the layer that we're going to add now, it's just a plotting library. So we will try to create a line chart based on the log, and in the x-axis, we are going to set the parameter we want to display, which is going to be the sonic log. And on the y-axis, we're going to set the depth, right? So for the y-axis, let's use, let me show you one more time the data. So you can see basically what we're working with. So we have the depth. We can target the depth, and we can target the sonic, the dt. So for that, we will say the y-axis should be depth dt, and you will get this chart. Sorry, this should be depth, not dt. The y should be depth. So this is what you're looking at. This is a combined response from all the wells, and this is not correct. We have to split the responses from different wells. So for that, with a simple input, we will tell Python, well, we want to color these based on well name. And well name, it's called asset name in this data file. So once we do this, this is what you're going to get. You're going to get sonic response from all of these wells. Let me zoom in on a certain portion of the data. So these are basically responses from different wells. Okay. You can also do something like this. You can also split all of these wells into their own tracks, and they will look like this with a really simple addition to the same charting library. We can zoom in on any portion of the data, and then basically we can compare them. Maybe we can look at the data and explore the data. And now this is a problem. In this data set, what I'm going to do is I'm going to pass this in to the deep learning algorithm. I will tell deep learning algorithm, well, take a look at the data, understand the patterns. And what I want you to do is once you understand the pattern, try to predict the sonic for me. And basically the deep learning will understand how the pattern works. And basically it will ready for use. And this is the part that's going to be interesting. I have another file, which is called unseen. Now, this data file, it's totally blind to the machine learning, or it's totally blind to the deep learning algorithm. Deep learning it's not seeing this. And then what I'm going to do is I will throw this at the deep learning, and I will tell it, now try to predict the sonic for this file. And I will compare the actual results alongside with the calculated result. And I will show you how the deep learning can basically help you to generate missing curves, okay? So that's going to be a part of this. By the way, this is just a really simple implementation of the deep learning. It's not like all the things you do. No, it's a really simple one. Next thing that we need to do is we will start to create some features that we want to train, or features is basically the things that we want the machine learning to take a look at, or the deep learning to take a look at, and basically understand the patterns. Okay? So for that, we will say that we want the machine learning to take a look at the track called neutron phi, and take a look at shale volume, and then take a look at rho bulk, or the density. And we will tell the machine learning based on these things and based on the interaction that will happen between these parameters and the relationship between them, I want from you to predict me a target of sonic. By the way, the target can be different. It can be sonic, it can be porosity, it can be even the lithology type. It depends on the type of problem you're trying to solve. But in this case, I'm going to predict the sonic. So for this, now we need to reduce down our data into all of these variables that we've selected. So we will say logs of features. Now these are going to be the training parameters, and for the other parameters that are going to be the prediction, which is a y. So y equals to the target data, and we need to run this. So yeah, actually this is called logs. So we need to run this. It's called logs, and this is called logs. There we go. Now, if we take a look at the X data, it looks like this. The X data contains neutron phi, shale volume, and rho bulk, and the Y data contains just one column, which is the DT. Okay, and of course, there are lots of steps that are missing from this. So I am not claiming that this is the full steps that you would take for AI. Actually, that's far from the truth. There are lots of steps that are going to be in between, and mostly these steps are related to modeling the data and basically making sure the data is correct and is in the right shape and the format. The next thing will be is to create the model. So let me show you how to create the model. So we will, for the model, we're going to use a library called TensorFlow. And from TensorFlow, there is an interface called Keras. So we're going to use that. And Keras, its short is KS. So from Keras, I am going to call a sequential model. Basically, a sequential model is a model that's going to be solved from left to right and then back from right to left. So this is what sequential model is. And in this sequential model, I'm going to have certain input layers because we know that deep learning is based on layers. So this is how the model is architectured. It's architectured as layers, as I have already showed you in these. And you can see every picture I showed you in the deep learning process, it's just basically some layers stacked next to each other and sometimes stacked on top of each other. So these layers basically talk to each other to understand the data pattern. So this is basically what we're creating. We're creating a sequential layer. So the first layer is usually going to be what? It's going to be the input layer. And that's why we're going to create an input for this. So, and we will tell this Keras, well, we have an input of 3. Okay, so we need to say that the shape of the input is 3. And once we have the input, we will move to the next layer, which is going to be the processing layer. I will create a really weak model so for you to see how we can improve this afterwards. Okay, so next thing is going to be the processing layers, or these are known as hidden layers. So we are going to add a layer that's going to have 16 nodes. So 16 here means we are going to have, let me show you. So we're going to have 16 of these points. So what you're seeing, this is 4. So let me show you. Or let's open up the drawing application. So 16 means that we're going to have 16 of these cells. Well, basically, these are called neurons. 16 of these, and based on 16 of these, your data will be split among these. And machine learning will start, or sorry, deep learning will start to understand the patterns between them. So this is what the 16 looks like. And these are 12. And this is 16. So basically, your data will be splitted between these nodes. And then we will add another layer to this that's going to be showing you the patterns. So the next layer that I'm going to add, I will make sure that the next layer is the double of the other layer. Why I am choosing it is, well, because this is usually, it comes from experience. So yeah, this is what's going to happen. The layers are going to be connected to each other, and then they will basically pass informations back and forth in order to basically reveal the pattern and understand what's happening. So this is what's going to happen. So the 16 basically denotes the number of layers. So the number of nodes I want in a single layer. Okay, and then we're going to activate the layer by something called ReLU. This is called an activation function. So for now, just ignore the existence of this activation function. Let's add one more layer. So Keras layers dot dense. It's dense means that everything is connected together. And the next layer is going to be 32 cells or 32 neurons, and activation is going to be ReLU. And let's keep it like this. And then we will have a single output layer. That will be Keras layers dot dense. So that's going to be a single output layer. Okay, so we will have one output. By the way, if you're working with probabilistic modeling, if you're working with probabilities, you will have multiple outputs. Each output will have its own probability. For example, maybe you want to predict some problem. Maybe you want to predict if your well is producing, or if it's seized, or the well having a certain problem. These things can have probabilities. So for example, machine learning or AI will tell you that the probability of this well being seized is 30%, while the probability of this well being active is like 70%. This is probabilistic approach. So that's why you can also increase the number of outputs. If you put 2 outputs, this basically generates a probability for you. Okay? So yeah, it's really flexible, and it really requires you to understand how basically these things work in order to effectively start using them. Once we have our model, by the way, this is a really simple model. Let's start to compile this model and basically put everything together. So we will say model.compile. And for model compilation, we will tell the model to optimize it using an algorithm called ADAM. It's just an algorithm. Okay? And we will say that for loss function, so loss function is basically how your model is improving itself based on a certain error, which is called loss. In the terms of AI, loss is just the error term, or how much improvement you're getting over the training. We will say that we're working with mean square error. And let's say we're also trying to monitor the mean square error, and we are trying to also monitor the MAPE. MAPE is basically the percentage of error you have. And we will run this model. There we go. Now you will get the green check. The green check means that everything looks good, but it does not mean the model will run and perfectly. Now let's try to run the model. We will say model.fit. Fit basically starts the training process. So for the fit needs 2 things. It needs the X data and it needs the Y data. Well, basically we already have these. There we go. Once we run this, the model started. And basically what we did is we run the model, but yeah, the model is not very correct. you will see that the error we have is 92%. It is, yeah, the error is too much for this. Yeah, it's too much. Plus, the model is losing a lot on accuracy. So there must be certain things that we can do. So the first thing that we will do is we will increase the number of epochs. So epochs is how many passes your algorithm will do in order to find in the results. So let's say that we want 10 passes. Okay. So we will run this and you will see at each pass, your model is improving. So basically we dropped from like 92% to basically to 10% error. And actually we can also improve this. Let me show you how. We can also control how the data is being flowed into these nodes. We will say that the maximum data I am going to be allowed to be inserted in a single cell is 32 data points per time. This is what the batch means. So we will run this one more time, and basically the model will start to improve itself as you add more layers and you add basically more things to this. Okay. We can basically ultimately sometimes if you have lots of data and the pattern is not very evident, you will even increase this to up to 1,000 epochs. Okay. So by the way, the more you train this, the more accurate the model should be, but this is not always the case. And the more time it's going to consume, especially if you have big data, like drilling data, these models can take up to 30 minutes in training. Sometimes it's even more. By the way, the ChatGPT models takes months into training. So yeah, like 30 minutes, it's not like that much. Okay? So let's say that this is the model and we are happy with our model. Now let's see what the results look like. Okay. We train the model. So the model is trained. And by the way, there is a good thing about deep learning that does not exist in other machine learning models. Let's say that you have trained this model based on this certain data. If you get new data, you will continue from where you're left off. You don't have to train from the beginning. This is called transfer learning. That's why whenever you ask things from ChatGPT, ChatGPT will answer you based on its newer experiences. It's not going to train, it's not going to say, well, just wait for me to train one more time on your data and then I will get back to you. No, ChatGPT will start to answer you based on the previous interacts you had with them. Why is this? Because ChatGPT uses something called transfer learning, which is same technology that we are going to use in this training. Okay. Let's say we want to train this couple of more times, and you can see each time we train, well, the error is getting better and better. Why is this? Because the deep learning model basically knows what we did earlier. So let's increase the epochs to 30. Now you can see the percentage error. Actually, it's getting less and less each time that we're training it. And this is a really suboptimal model. This model is called a shallow model. We can also convert this into a deep model by increasing the number of layers. This is something that I'm going to show you just now. First of all, let's start visualizing this. Okay, so we have a figure that basically contains two compartments. Basically, it contains three compartments: 1, 2, 3. The first compartment, I'm going to show you the older sonic responses from the other wells. And in the second compartment, I am going to read the unseen well, and I'm going to show you the results for these as well. Okay? For this, we need to start reading the unseen well. Okay? So we will start reading the hidden well. So hidden well equals to pandas, which is a library that is used for reading data, PD, it's called PD. And we will read unseen data. Okay? And if I show you the data, it looks like this. Now, this is totally unseen. Even the data structure is very different from the other table. Okay? So we will use this hidden in order to basically predict sonic. And then I will compare the sonic that we have with this file. So basically, this will set us up. If we have like other wells that are old wells that do not have sonic, we can generate sonic based on the older data. We will create a new X. So the new X will be hidden data of features. And believe it or not, that's it. Let me show you. We can create predictions. So model.predict. Now we're just going to predict based on the new X. Okay. So let's run this. There we go. Now this is the prediction. It's already run. Let me show you what the prediction looks like. There we go. Now these are the sonic values that were generated. Okay. So let me flatten this data so we can easily save this. What I'm going to do is I'm going to do a trick. I will add the predictions next to the original data. So we will say hidden. I will create a new column called DT predicted. equals to the prediction. And I'm going to show you what the table is going to look like. There we go. Now you have two DT readings. One DT is from the original reading and one DT is from predictions. Of course, some of these match really closely and some of these do not match because your data is not explaining these patterns. Let me show you what these look like in plot. So let me show you the plots. So we will say plotly express dot line. I'm going to create a line chart. And the line chart is coming from the hidden data. The x-axis is going to be two things at the same time, which is the sonic and then the predicted sonic. So basically, you can compare both of these, DT predicted, okay? And of course, we need a reference for these. So the reference is going to be the depth. So y equals to depth. Run this, there we go. Now this is the DT, original DT, and this is the predicted DT, okay? So for this, I need to modify a few things more. So we will modify the width of the chart. Let's make this 400 and the height of the chart. So the height of the chart is going to be 1,000. Okay. So now this is what it looks like. Okay. So there are certain parts of the model it's predicting really accurately, and some parts are really far apart. So why this is happening? Because the data we have, it might not explain the full complexity of this, but yeah, it's really accurate, especially the pattern that it's detecting, like this one, this one. Let's improve this. We will go scroll on the top. We can include like any variable we want. Maybe we want to include the resistivity. Maybe we want to include the photoelectric. Or maybe we want to include the porosity. So more data, the more data you include, the more accurate the result will be. This is actually at least theoretically. So you would try multiple things in order to get and reach the accurate value. So one of the things that you can do is you can make this or convert this shallow network into a deeper network. Let me show you. You can add more layers to this. Okay? So the more layers you add, supposedly the more patterns it should detect. So let's make sure that the layers are really deep. Let's run this. Okay, now let's go to compilation. Or let's go to the prediction. So for some reason, we're getting duplicate data. So let's delete these. So let's see. Okay, so let's make sure that the training goes one more time. Let's start from 20. There we go. Now you can see it's already improving and the error is minimal. You can see the training is happening. You have like 4.6% error, like it's overall error. The thing that I can do is either I increase the size of batches and increase the training epochs. So I will make 100 training epochs and I will try to evaluate the model from there. Now the training should go on and on. By the way, there are lots and lots of parameters that you can control in order to make the training more accurate. Let's run for 500 iterations or 500 epochs. This way, the model gets understanding of the different patterns in the data. Okay, now that the training is done, and you can see you have already reduced the mean square error and the absolute error percentage error is only 4%. So let's run this one more time and let's see if there's an improvement. Well, there is a slight improvement in our data. So if you want to make sure that this is more improved, you can also add more data to this. You can add lots of other things to this, like increasing the number of layers, changing the activation, increasing the number of observations you have, like in the features. Okay, so now let me show you how we can put everything together in a single plot or in a single visualization. So we will call the figure dot add traces. And from this, what I'm going to tell it, I will tell it that to add this figure of predicted figure. Let's call this predicted figure. So predicted figure dot data. So we will add this. Now we are going to get this chart. Okay. And then I'm going to add like all the data, all the well data from other wells next to it. So that's going to be from this line, this one. Let's copy this. And let's make sure that original, let's call this original data or original figure equals to same chart. Yeah. But this time we're going to add this figure dot add traces. So we're going to get all the components from this chart as well. Original data or original figure of data. And we will tell it to put it in the second column. Run this. There we go. Now this is the original data and this is the predicted data. So basically these sonics basically contribute to this one. If we zoom in, this is basically what it looks like. We can also make sure the chart is longer. Height equals to 1,000. There we go. And these are all the responses from the other wells. And the more responses you have, the more accurate the result will be, by the way. Okay. So let me show you one more thing. You can easily, once you build the model, it's really easy. You can flip the target to any parameter you want. Let's say that you want to predict the porosity. Just swap it like this. Everything will start to work. Run this and train the model one more time. Now the model is training. Some more tweaks that can be, for example, can be done, like improving the phi data. Maybe you have some problem with the data, you can also remove that. There we go. Now this mean square error looks okay. Now I think we can go ahead and also plot the porosity as well. So let's open a new chart. So let's call this phi predicted. And let's do this phi. Let's also plot the porosity. Now you see a one model can be converted into multiple models at the same time. So yeah, it's really flexible. Once you have one model figured out, everything else can be basically different or can be basically derived from the same thing, but for different results. Okay, so let's run this and try to predict this. There we go. Now we have successfully predicted the porosity as well. Okay, you can see some porosities are really out of the range. Let's see why. Okay, so we can actually, we need to define this one more time. So yeah, let's go back and run this. There we go. Now this is the porosity response. And you can see the model for the porosity is way more accurate than the sonic because because the data pattern it's way easier to detect for this pattern for this parameter apparently. So you can see now this is the porosity response for this well that's totally unseen. Okay, so yeah, this is just some of the usages that you can do for machine learning, sorry, artificial neural networks and deep learning and all of these parameters you can predict from. Next session, I'm going to show you how to detect some events on some well problems and basically how you can create also decision boundaries and basically where the problems and where the probabilities occur for these types of problems. Thank you so much for joining.